Hi! Today, we will learn about quadrilaterals. What do we mean when we say quadrilateral? Quadrilateral came from the Latin word quadri, which means four, and latus, which means side. So when we say quadrilateral, it means four sides. A quadrilateral is a polygon with four sides. Let us try to recall what is being described in each. Number 1, a quadrilateral that has two pairs of parallel sides. That is a parallelogram. Next, a quadrilateral with four congruent sides. That is a rhombus. Next, a polygon with four sides is a quadrilateral. Next, a quadrilateral with two distinct pairs of congruent adjacent sides is a kite. Next, a quadrilateral with four right angles, it is a rectangle. A quadrilateral with exactly one pair of parallel sides is a trapezoid. A line segment joining two opposite vertices of a quadrilateral is called diagonal. A quadrilateral with four congruent sides and four right angles, it is a square. The diagram here shows the family of quadrilaterals. So a quadrilateral is divided into three types. First type is a quadrilateral with one pair of parallel sides. This is a trapezoid. One special type of trapezoid is what we call isosceles trapezoid. An isosceles trapezoid is a trapezoid wherein the non-parallel sides are congruent. The second type of quadrilateral is that which has two pairs of parallel sides, and this is what we call parallelogram. Under parallelogram, we have rhombus and rectangle. A rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And here, we also have a square. So as you can see, a square has all the properties of a rhombus and a rectangle, since square has four congruent sides and four right angles. The third type of a quadrilateral is that with no parallel sides, and that is a kite. A kite is a quadrilateral with two pairs of distinct congruent adjacent sides. Before we proceed to our lesson, let us first familiarize ourselves with some terms that we will encounter as we go along with this lesson. First, we have consecutive vertices. Say, for example, we have quadrilateral MATH. So when we say consecutive vertices, these are any two vertices that are connected by a side. Say, for example, vertex M and vertex A. They are two consecutive vertices. Another example, vertex A and vertex T. Another pair of consecutive vertices are vertex H and vertex T. Another one, we have vertex M and vertex H. They are also consecutive vertices. Another term, we have adjacent sides. Adjacent sides are two sides with a common endpoint. So from the given figure, let us identify two adjacent sides. Side MA and side AT are two adjacent sides. Another example, side MH and side HT. They are two sides with a common endpoint, so we consider them adjacent sides. Another example, we have side AT and side HT. Another pair of adjacent sides are side MH and side HT. Next, we have opposite sides. So when we speak of opposite sides, it means two sides having no common endpoint. From the given figure, example of opposite sides are side MA and side HT. Another pair of opposite sides are side MH and side AT. Next, we have opposite angles. So when we speak of opposite angles, it means two angles having no common side. Example, angle M and angle T. Another example of opposite angles are angle A and angle H. Next, we have consecutive angles. When we say consecutive angles, it means two angles whose vertices are the endpoints of a side. Example, angle M and angle A are two consecutive angles. Another one, angle A and angle T. Another pair of consecutive angles are angle M and angle H. Another one, we have angle H and angle T. Angle H and angle T are also consecutive angles. As you can see, they are connected by a side. Next, we have diagonal. A diagonal is a line segment joining the vertices of opposite angles. Example of a diagonal is diagonal MT. Another one, diagonal AH. So aside from these terms, we must also be familiar with some geometric symbols. This is the symbol used for angle. This is the symbol used for parallel. This one is used to represent triangle. This symbol represents congruent. And then we make use of two capital letters to represent line segment. And this symbol is used to represent parallelogram. Quadrilaterals that are parallelograms. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So if quadrilateral ABCD is a parallelogram, as you can see in the figure, both pairs of opposite sides are parallel. It means that side AB is parallel to side CD, and side AD is parallel to side BC. Rectangle, rhombus, and square are parallelograms. Let us now proceed to the properties of a parallelogram. First property, in a parallelogram, any two opposite sides are congruent. So if HOPE is a parallelogram, it means that side HO is congruent to side EP, and side HE is congruent to side OP. Next property, in a parallelogram, any two opposite angles are congruent. So if JUST is a parallelogram, it means that angle J is congruent to angle S and angle U is congruent to angle T. Third property, in a parallelogram, any two consecutive angles are supplementary. So if GIVE is a parallelogram, it means that consecutive angles are supplementary. So when we say supplementary, the sum of these two consecutive angles is 180 degrees. Angle G plus angle I is 180 degrees. Angle I plus angle V must be equal to 180 degrees. Same with angle V plus angle E. And also angle E plus angle G. So the sum of two consecutive angles in a parallelogram is always 180 degrees. Fourth property of a parallelogram. The diagonals of a parallelogram bisect each other. So if HELP is a parallelogram, it means that diagonal HL and diagonal PE bisect each other. When we say they bisect each other, they divide each other into two equal parts, which means that if S is the intersection of diagonal HL and diagonal PE, it means that HS is congruent to SL and PS is congruent to SE. Fifth property of a parallelogram. A diagonal of a parallelogram divides the parallelogram into two congruent triangles. So let's say we have parallelogram ABCD. So if we have diagonal AC divides the parallelogram ABCD into two congruent triangles. And what are the two congruent triangles? We have triangle DAC and triangle BCA. So it means that triangle DAC is congruent to triangle BCA. Same with the other diagonal. So here let us illustrate the other diagonal. So we have parallelogram ABCD. So if we draw diagonal DB, it means that if ABCD is a parallelogram, diagonal DB divides the parallelogram also into two congruent triangles. So we can say that triangle ABD is congruent. Triangle ABD is congruent to triangle CDB. So those are the 5 properties of a parallelogram. Note that all the properties of a parallelogram are also properties of any rectangle, rhombus, and square, since rectangle, rhombus, and square fall under parallelogram. Conditions that guarantee a quadrilateral a parallelogram. First condition, a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Next condition, a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. Third, a quadrilateral is a parallelogram if both pairs of consecutive angles are supplementary. Next, a quadrilateral is a parallelogram if the diagonals bisect each other. Next, a quadrilateral is a parallelogram if each diagonal divides a parallelogram into two congruent triangles. And last one, a quadrilateral is a parallelogram if one pair of opposite sides are both parallel and congruent. Let us now proceed to finding the measure of angles, sides, and other quantities involving parallelograms. Example number 1. Given quadrilateral ABCD, with angle A equal to 105 degrees, angle B equal to 75 degrees, angle C equal to 105 degrees, and angle D equal to 75 degrees. What condition guarantees that quadrilateral ABCD is a parallelogram? First, let us try to illustrate quadrilateral ABCD. So let's see, this is quadrilateral A, B, C, D. So according to the problem, angle A is 105 degrees, angle B is 75 degrees, angle C is 105 degrees, and angle D is equal to 75 degrees. Now the question is, what condition guarantees that quadrilateral ABCD is a parallelogram? So we have learned that a parallelogram or a quadrilateral is a parallelogram if opposite angles are congruent. As you can see, angle A and angle C are opposite angles. They are congruent. Another condition that guarantees that this quadrilateral is a parallelogram is the condition that a quadrilateral is a parallelogram if consecutive angles are supplementary. So, two consecutive angles, say we have angle A and angle B. They are consecutive angles. Question is, are they supplementary? Yes, because 105 plus 175 is equal to 180 degrees. So that guarantees, that condition also guarantees that ABCD here is a parallelogram. So there you go. Angle A is congruent to angle C. Angle B is congruent to angle D. A quadrilateral is a parallelogram if both pairs of opposite angles are congruent. Example number 2. ABCD is a parallelogram in which angle A is equal to 110. Find the measures of angle B, angle C, and angle D. Let us first try to illustrate parallelogram ABCD. Okay, let's say this is parallelogram ABCD. According to the problem, angle A measures 110 degrees. So the question is, what are the measures of angle B, angle C, and angle D? Since it is given in the problem that ABCD is a parallelogram, it only means that parallelogram ABCD has all the 5 properties that we have discussed a while ago. So we can apply the given properties in finding the measures of the missing angles. First, in finding the measure of angle B, what property are we going to apply? So to solve for angle B, we will apply the third property that we have discussed a while ago. We said that in a parallelogram, consecutive angles are supplementary. So if angle A and angle B are consecutive angles, they are supplementary, or their sum is equal to 180. So if angle A is 110 degrees, it only means that angle B measures 70 degrees. So we have 110 plus 70, that is equal to 180 degrees. Now, to solve for angle C, we apply the second property, which says that in a parallelogram, opposite angles are congruent. So if angle A and angle C are opposite angles, they are congruent, which means that if angle A measures 110 degrees, it follows that angle C also measures 110 degrees. How about for angle D? Angle D measures 70 degrees. Since angle D and angle B are also opposite angles, which means that they are congruent. So these now are the measures of the missing angles. Example number 3. Two consecutive angles of a parallelogram ABCD are 3x minus 4 degrees and 3x plus 16 degrees. Find the value of x and find the measure of each of its angles. First, let us illustrate parallelogram ABCD. So say for example, this is parallelogram ABCD. According to the problem, two consecutive angles are 3x minus 4 degrees and 3x plus 16 degrees. Let us first choose two consecutive angles. So let's say we have angle A and angle B. Let's say that angle A measures 3x minus 4 degrees and angle B measures 3x plus 16 degrees. First, we find the value of x and then find the measure of angle A and angle B. Since angle A and angle B are consecutive angles, we can apply the third property that we have learned a while ago, which says that in a parallelogram, consecutive angles are supplementary. So if angle A and angle B are consecutive angles, and ABCD is a parallelogram, it means that angle A and angle B have a sum of 180 degrees. So we can say that the measure of angle A plus angle B is 180 degrees. Angle A is 3x minus 4 degrees. Angle B is 3x plus 16 degrees. Removing the grouping symbols, we have 3x minus 4 plus 3x plus 16 is equal to 180 degrees. Let us combine like terms. 3x plus 3x is 6x, negative 4 plus 16 is positive 12. So for x, we have 6x is equal to 180 minus 12. 6x is equal to 180 minus 12 is 168. Divide both sides by 6. Therefore, x is equal to 28. Since we now have the value of x, we can now solve for the measure of angle A and angle B by simply substituting 28 to x. Angle A is 3x minus 4. So we have 3 times the value of x, which is 28, minus 4. 3 times 28, that is equal to 84. So we have 84 minus 4, and that is equal to 80. Therefore, the measure of angle A is 80 degrees. So if angle A and angle B are supplementary and angle A is equal to 80 degrees, we can say that angle B measures 100 degrees. So their sum is 180 degrees. Or you can solve for angle B by substituting 28 to x. If angle B is 3x plus 16. We have 3 times 28 plus 16. 3 times 28 is equal to 84, and 84 plus 16 is equal to 100. Okay, so angle B measures 100 degrees. Example number 4. In a parallelogram ABCD, AD is equal to 4x minus 5, AB is equal to 6x minus 10, DC is equal to 3x plus 5. Find the measure of AD. Okay, let's say this is parallelogram ABCD. Let us illustrate. According to the problem, AD is equal to 4x minus 5. AB is equal to 6x minus 10. And DC or CD is equal to 3x plus 5. Find the measure of AD. In order to solve for the length of AD, we must first find the value of x. So in order to do that, we need to apply properties of a parallelogram that we have learned a while ago. So in this problem, what property are we going to use or apply? We can use the first property, which says that in a parallelogram, opposite sides are congruent. Side AB and side DC are opposite sides. If ABCD is a parallelogram, it means that AB is congruent to DC. So if AB is equal to 6x minus 10, we can equate it to 3x plus 5. Since the two sides or the two opposite sides are congruent, we can equate them in order to solve for the value of x. Combining like terms, we have 6x minus 3x. And on the other side of the equation, 5 plus 10. 6x minus 3x is 3x. 5 plus 10, we have 15. Divide both sides by 3. Therefore, x is equal to 5. In the given problem, we are asked to find the measure of side AD. Side AD is equal to 4x minus 5. So in order to find the length of side AD, we substitute 5 to x. So we have 4 times 5 minus 5. 4 times 5, 20. 20 minus 5, that is equal to 15. So it means that side AD is equal to 15. Example number 5. In a parallelogram ABCD, AC is equal to AE plus CE. AE is equal to 2x minus 2. And CE is equal to x plus 12. Find the length of AC. First, let us illustrate parallelogram ABCD. So let's say this is parallelogram ABCD. According to the problem, AC, so if we have AC, that refers to the diagonal AC. AC is equal to AE plus CE. Let's also have the other diagonal, which is BD. Now, the intersection of diagonals AC and BD is point E or E. In this given problem, we apply the fourth property that we have learned, which says in a parallelogram, the diagonals bisect each other, meaning each diagonal or the diagonals divide each other into two equal parts. So if AC and BD are diagonals of parallelogram ABCD, they bisect each other, which means that AE is congruent to CE and DE is congruent to BE. According to the problem, AE is equal to 2x minus 2 and CE is equal to x plus 12. Now the question is, or the instruction is, find the length of AC. In order to find the length of AC, let us first solve for the length of AE and CE by finding the value of x. Since AE is congruent to CE, it means that 2x minus 2 is equal to x plus 12. Let us combine like terms. We have 2x minus x, 12 plus 2. 2x minus x is x and 12 plus 2 is equal to 14. Now let us find the length of AE. AE is equal to 2x minus 2. Let us substitute 14 to x. So we have 2 times 14, 28. 28 minus 2 is 26. Therefore, the length of AE is 26. Since AE is congruent to CE, we can say that CE also measures 26. And since we are asked to find the length of AC, and AC is equal to AE plus CE, therefore we have 26 plus 26, which means that AC is equal to 52. So that is how we find the measures of angles, sides, and other quantities involving parallelograms. Thank you very much for listening.